Okay, next piece of the puzzle is we are going to make the sigmoid class for the sigmoid function. That's the function we'll be using it for the final nonlinear activation in the test case that we're going to be doing here shortly. And sigmoid, of course, takes any input and outputs a value between 0 and 1. It's another pretty simple one. So we are gonna in the constructor, we're gonna allocate the output and the derivative of the inputs. The derivative of this function that will go back to the previous layer. Then all we have is the usual forward function and backward. And you can look up the equation for sigmoid function. It's pretty simple, and it's just 1 over 1 plus the e to the negative x. The e to the negative x, e to the whatever value you have you're supplying to it. So each entry of the matrix is going to be that x value that you'd plug in. So it's just 1 divided by 1 plus negative x, or negative value at that place in the matrix of inputs. And it's that simple. So we'll save that, go back over here. We can even make a couple of different layers. To go through. Let's see. So we can make this one's input dimension be the number of neurons, and number of neurons again, true for the layer bias. And let's see, so and then make another ReLU activation. So he'll be the second layer, which will be made of, the input will be the first ReLU's output, and then the second ReLU will take the second dense layer's output. And that's when we'll have the sigmoid which will take the number of samples and the number of neurons. I guess we'll see if that works, even with the squiggles. Actually, sorry, we don't need this one since we'll be using the sigmoid function. because I forgot to declare them public. That could help. So let's take that forward. So instead of doing the output here, and we can just keep printing them. The output of LD2 of this output of the sigmoid function as well. And let's see what pops out. So output of the first layer, and then zeroes out with the ReLU. Output of the second layer, and then these are the sigmoid. It's hard to tell because everything looks like a small number, but if we change this to 10, should get bigger numbers on everything else. So we get larger numbers than 1 here, as well as here. Let's make it even bigger to get all those numbers looking bigger. See, larger numbers on the output of the second layer, and everything here between 0 and 1 to give probability of yes or no, basically.